Hello, welcome to IT Expert YouTube video series. Today we are going to talk about machine learning. What are the different types of machine learning? Is a subcategory of artificial intelligence that refers to the process by which computers develop pattern recognition, or the ability to continuously learn from and make predictions based on data, then make adjustments without being specifically programmed to do so. There are three types of machine learning: supervised learning, unsupervised learning, reinforcement learning. Supervised learning. Supervised learning uses statistical modeling with labeled input-independent variables to predict, classify, and output. Dependent variable. This can be both regression linear, logistic, SVM, Poisson, neural networks, survival, and classification. This can be applied for a wide variety of business applications like propensity to buy, market media mix models, attrition risk, market basket, customer segmentation. Unsupervised learning. Unsupervised learning uses statistical modeling with unlabeled data to discover patterns in the data using clustering methods like k-means, hierarchical clustering. This is used for segmentation of data and discovering complex data structures that can use for supervised learning. Reinforcement learning. Using reinforcement learning, the model can learn based on the rewards it received for its previous action. Consider an environment where an agent is working. The agent is given a target to achieve. Every time the agent takes some action toward the target, it is given positive feedback. And, if the action taken is going away from the goal, the agent is given negative feedback. What is clustering? Clustering is the process of grouping a set of objects into a number of groups. Objects should be similar to one another within the same cluster and dissimilar to those in other clusters. A few types of clustering are hierarchical clustering, k-means clustering, density-based clustering, fuzzy clustering, etc. What is classification? Classification is defined as the process of recognition, understanding, and grouping of objects and ideas into preset categories, aka subpopulations. With the help of these pre-categorized training datasets, classification and machine learning programs leverage a wide range of algorithms to classify future datasets into respective and relevant categories. Classification algorithms used in machine learning utilize input training data for the purpose of predicting the likelihood or probability that the data that follows will fall into one of the predetermined categories. One of the most common applications of classification is for filtering emails into spam or non-spam, as used by today's top email service providers. In short, classification is a form of pattern recognition. Here, classification algorithms applied to the training data find the same pattern, similar number sequences, words or sentiments, and the like in future data sets. We will explore classification algorithms in detail, and discover how a text analysis software can perform actions like sentiment analysis used for categorizing unstructured text by opinion polarity, positive, negative, neutral, and the like. Strengths and weaknesses of the decision tree approach. The strengths of decision tree methods are: decision trees are able to generate understandable rules. Decision trees perform classification without requiring much computation. Decision trees are able to handle both continuous and categorical variables. Decision trees provide a clear indication of which fields are most important for prediction or classification. The weaknesses of decision tree methods. Decision trees are less appropriate for estimation tasks where the goal is to predict the value of a continuous attribute. Decision trees are prone to errors and classification problems with many classes and a relatively small number of training examples. Decision tree can be computationally expensive to train. The process of growing a decision tree is computationally expensive. At each node, each candidate splitting field must be sorted before its best split can be found. In some algorithms, combinations of fields are used and a search must be made for optimal combining weights. Pruning algorithms can also be expensive since many candidate subtrees must be formed and compared. What do you understand by decision tree in machine learning? Decision trees can be defined as the supervised machine learning, where the data is continuously split according to a certain parameter. It builds classification or regression models as similar as a tree structure, with datasets broken up into ever smaller subsets while developing the decision tree. The tree can be defined by two entities, namely decision nodes and leaves. The leaves are the decisions or the outcomes, and the decision nodes are where the data is split. Decision trees can manage both categorical and numerical data. Central tendency. Statistics is an important branch of mathematics that is widely used in a variety of traditional disciplines like economics, commerce, research, surveys, etc. In this present digital age, emerging technologies like data science and machine learning have boomed up. These technologies are also centered around statistics. After all, statistics is all about the collection, interpretation, and presentation of data. Basically, statistics provide insights into the data. Measures of central tendency. An essential statistical concept is the measure of central tendency. This measure is an important way to summarize the dataset with one representative value. This measure provides a rough picture of where data points are centered. The commonly used measures of central tendency are mean, median, mode. Average value is termed as the mean of the dataset. It is very easy to calculate the mean. Variability. Variability, also known as statistical dispersion, is another feature of descriptive statistics. Measures of central tendency and variability together comprise of descriptive statistics. Variability shows the spread of a data set around a point. Measures of variability. Following are some of the measures of variability that are offers to differentiate between data sets. Variance. Standard deviation. Range. Mean deviation. Interquartile range. What is machine learning regression? Regression is a method for understanding the relationship between independent variables or features and a dependent variable or outcome. Outcomes can then be predicted once the relationship between independent and dependent variables has been estimated. Regression is a field of study in statistics which forms a key part of forecast models in machine learning. It is used as an approach to predict continuous outcomes in predictive modeling, so has utility in forecasting and predicting outcomes from data. Machine learning regression generally involves plotting a line of best fit through the data points. The distance between each point and the line is minimized to achieve the best fit line. A regression problem is when the output variable is a real or continuous value, such as salary or weight. Many different models can be used. The simplest is the linear regression. It tries to fit data with the best hyperplane which goes through the points. Types of regression models. 1 simple regression model. Linear. Non-linear. 2 multiple regression model. Linear. Non-linear. Challenges of machine learning. The advancement of machine learning technology in recent years certainly has improved our lives. However, the implementation of machine learning in companies has also brought up several ethical issues regarding AI technology. A few of them are: technological singularity. Although this topic attracts lots of attention from the many public, scientists are not interested in the notion of AI exceeding humans' intelligence anytime in the immediate future. This is often referred to as superintelligence and superintelligence, which Nick Bostrom defines as any intelligence that far surpasses the top human brains in virtually every field, which includes general wisdom, scientific creativity, and social abilities. In spite of the fact that the concept of superintelligence and strong AI is not a reality in the world, the concept poses some interesting questions when we contemplate the potential use of autonomous systems, such as self-driving vehicles. It is impossible to imagine that a car with no driver would never be involved in a car accident, but who would be accountable in those situations? Do we need to continue to explore autonomous vehicles, or should we restrict the use of this technology to produce semi-autonomous cars that encourage the safety of drivers? The jury is not yet out on this issue. However, these kinds of ethical debates are being fought as new and genuine AI technology is developed. AI impact on jobs. While the majority of public opinion about artificial intelligence revolves around job loss, the issue should likely be changed. With each new and disruptive technology, we can see shifts in demand for certain job positions. For instance, when we consider the automotive industry, a lot of manufacturers like GM are focusing their efforts on electric vehicles to be in line with green policies. The energy sector is not going away, but the primary source that fuels it is changing from an energy economy based on fuel to an electrical one. Artificial intelligence must be seen as a way to think about it, as artificial intelligence is expected to shift the need for jobs to different areas. There will be people who can control these systems as data expands and changes each day. It is still necessary resources in order to solve more complicated issues within sectors that are more likely to suffer from demand shifts, including customer service. The most important element of artificial intelligence and its impact on the employment market will be in helping individuals adapt to the new realms that are a result of the market. Privacy. Privacy is often frequently discussed in relation to data privacy security, data protection, and security. These concerns have helped policymakers advance their efforts recently. For instance, in 2016, GDPR legislation was introduced to safeguard the personal information of individuals within Europe's European Union and European Economic Area, which gives individuals more control over their data. Within the United States, individual states are creating policies, including the California Consumer Privacy Act (CCPA), that require companies to inform their customers about the processing of their data. This legislation is forcing companies to think about how they handle and store personally identifiable information (PII). In the process, security investments have become a business priority to remove any potential vulnerabilities or opportunities to hack, monitor, and cyber attacks. Bias and discrimination. Discrimination and bias in different intelligent machines have brought up several ethical issues about using artificial intelligence. How can we protect ourselves from bias and discrimination when training data could be biased? While most companies have well-meaning intentions with regard to their automation initiatives, Reuters highlights the unexpected effects of incorporating AI in hiring practices. As they try to automate and make it easier to do so, Amazon unintentionally biased potential candidates based on gender in positions in the technical field, which led them to end the project. When events like these come to light, Harvard Business Review link located outside of IBM has raised pertinent questions about the application of AI in hiring practices. For example, what kind of data could you analyze when evaluating a candidate for a particular job? Discrimination and bias are not just limited to the human resource function. They are present in a variety of applications ranging from software for facial recognition to algorithms for social media. Accountability. There is not a significant law to control AI practices. There is no mechanism for enforcement to make sure that ethical AI is being used. Companies' primary motivations to adhere to these standards are the negative effects of an untrustworthy AI system on their bottom lines. To address the issue, ethical frameworks have been developed in a partnership between researchers and ethicists to regulate the creation and use of AI models. But, for the time being, they only serve as a provide guidance the development of AI models. Research has shown that shared responsibility and insufficient awareness of potential effects are not ideal for protecting society from harm. How is machine learning used in day-to-day life? Most of the people are already using machine learning in their everyday life. Assume that you are engaging with the internet, you are actually expressing your preferences, likes, dislikes through your searches. All these things are picked up by cookies coming on your computer. From this, the behavior of a user is evaluated. It helps to increase the progress of a user through the internet and provide similar suggestions. The navigation system can also be considered as one of the examples where we are using machine learning to calculate a distance between two places using optimization techniques. Surely, people are going to more engage with machine learning in the near future. Thank you for watching this video. We provide hands-on training with labs, homework, group projects. Prepare you for the certification. Provide real projects. Internship opportunities. Support you in Resume, LinkedIn. Staffing support. Provide tech references. In-person, online class. Class retake options and more. Call us at 847-350-9034 for your free career consultation meeting. Please do not forget to like, share, and subscribe to our channel for the latest videos.